So we are going to create a thread pools from scratch. Okay, we're not going to use the existing one. The idea is this thread pool is not going to be exactly similar to the one we regularly use using the executor service. The reason we are doing this just to get some idea how thread pools works. Thread pool works, and you can have some underline the concept. And if we have to develop or do something by ourselves, would be able to do it, right? So the basic idea is thread pool is basically a bunch of threads. They will be when we're going to create the object of thread pool. The threads are going to get created by that time, and we can just submit task, submit the job whenever we want to do. The reason is simple. The creating threads actually has some overhead, so we don't want to create a lot of threads whenever we need it. Rather than we are going to create threads initially from, like, let's say when we are going to start the application, we're going to create a bunch of threads, and then they will be staying and keep running as long as the application, or we are not explicitly shutting them down. Okay, so that's the idea. So we're going to have an interface over here first. Let's define the methods. First few methods which we're going to use over here. First of all, we're going to have a submit method. Basically, we're going to provide some task using this. So the simple way of providing a task is using runnable method. So we're going to use that, and there will be another method which would be called callable. The reason is this runnable method has only one method which is run, so it doesn't return anything. Sometimes we want to provide a task or a job, and we want to get something out of it, right? So the runnable method actually doesn't do that. It just executes something, and that's why we needed another method which is going to be we have a different interface called callable. We're going to use that over here, and it's going to return something. Okay, just a minute. So the method would be this is going to return something. It can be anything, any objects. So the return type would be future. The reason of using future is we are not definitely sure when this task will be finished. So the future would be a reference from where when the task is finished, we are going to get the result. Okay, and so the method would be same, submit, and we are going to use callable interface, and it's going to take T jobs, and T is basically a replacement over here. It can be anything. It can be any object, any class. So that's the method. And if you want to see the callable method, you can see it basically returns something. So from using this method, we're able to get the result. So we have two methods. These two methods is basically needed, and we're going to have another method which is going to shut down the thread pool. So that's going to be what shut down. Basically, so if we have a 20 threads in the thread pools, they are going to run until we shut them down. So they are going to keep running. Okay. So these are the three methods we're going to have in this thread pool, and let's implement this. It's going to be very simple. We have we can just use the context menu over here and implement the interface. Okay, so over here we have these three methods. These are the methods we are going to implement. So the idea is let's create a main method for let's create a demo first. Let's say demo, and this is our client class where we're going to use this thread pool. So we have a main method over here. So let's say this is our main method, and for our pool, new thread pool. So sorry, it's going to be until, because we named it that way. We could definitely name something else, but since we had an interface over here, that's why we named it as an implementation. But we don't we really don't need to do that, right? For example, if we are not, if we would not actually use this, we have a class library in this Java, which is called executors, and we can use this, right? These are definitely the best, and you should not use this example in your production system. You definitely should these available thread pools. These are developed in a fine-tuned way, and these are the best. I'm just providing the idea how it works behind the scenes. It's definitely the simplest implementation. So in the pool, how we're going to use, we're going to submit some task, right, using the runnable interface and the callable interface. We definitely want to specify the number of thread we are going to have in this thread pool, so we can definitely provide a number over here. If we want to do that, we definitely need a constructor. So let's create a constructor, and we can definitely do, let's comment out this one, and let's create a constructor. So it's going to take an integer, and let's name it thread count. And the first thing, when we're going to take a argument from be it methods, be it the constructor, we need to validate the input. So for example, this thread count can be negative. User can put a negative integer, and definitely the negative integer, we would not be able to create threads with the negative right? And definitely user can provide a huge number, right? We should limit the number of threads. For example, the number of threads is, let's say, 1024. So we will not allow users to have more than 124 threads. So that way, we're going to create a constant over here, static final int max allowed thread. Let's say it is 1024. So in first line, we're going to validate the thread count. If thread count is greater than smaller than 0, or thread count is greater than max allowed thread, then this screen is not right. So let's fix that. Okay, I used extra L over here. Okay, so we're going to throw an exception, throw illegal argument exception, and we definitely use a useful message, which is max allowed thread count is max. So that way, if we add, for example, let's do see the example. So if we use like 20,000, then we'll definitely not be able to create a thread pool. So we're going to get an exception. Let's see. We have got an exception. So it says max allowed thread count is 124, and if we add a -1, this is going to be this is also going to an exception, through an exception. So we're not definitely going to do that. Let's keep it for 20 for now. So now, since we have validated the count, now we're going to create some threads, right? So let's assume we are going to create thread over here. So we'll complete this thread creation. Let's move into this method first. Submit. So the idea is it's going to be a queue, right? So we're going to add a lot of tasks one by one, and the threads that we are going to create in this pool, they are going to pick one and then execute. And when it's done, it's going to take another one and pick and execute. This is how it's going to work. So we need some sort of data structure to hold the task, hold the jobs, right? So for that, we can use a queue, and there is a special queue called blocking queue. We're going to use that. The reason I'll explain later. Run, let's say name it run queue, and we are going to use linked blocking queue. The data structure is extremely thread safe, and the reason is it is primarily designed for a special case called producer consumer queues. Let me explain in a different image, which is, let's say this is a queue, and the one thread is responsible for putting some task, and another thread is responsible for taking those tasks. And if there is a difference in this number, for example, when this thread 2 is taking task and there is no task available in this blocking queue, it might get an exception, right? And on the other hand, we can have a different situation. For example, blocking queue has a size of let's say 20, and the another case is trying to put in some jobs, but the queue is already full, so there will be an exception, right? So and when there is an exception, thread is going to interrupt it and thread is going to exit, right? There are some other implication over here as well. So I'm not going to get into details on this, but the blocking queue actually solve all of these issues. So let's just use it for now, and we can definitely discuss this producer consumer the problem in different session or different videos. Okay, so this submit would be simple. So we have a run queue, and we're going to just add jobs over here. So this is going to, as long as we're submitting, the run queue will going to add these jobs into the back of the queue. Now, since we have a queue, someone has to be responsible for taking those jobs, right? Let's create a method over here. So let's keep it private. Right, check. So this one is going to basically take a jobs from the queue. So let's it's our jobs, right? So basically it's going to take a job from the queue, and let's not make it quiet rather than runnable. Runnable is basically our jobs, and the take method actually throws an exception. So let's handle that. I mean, we're not going to use try catch, rather than use use this throws keyword in this method, and we can just return it from over here. All right, that's all we need. And now we're going to create a private class over here. Let's name it worker, and worker is going to be our threads that we're going to create while we're let's name it a class called private class worker, and it's going to take it's going to extend threads. So these are the threads. Basically, we are extending the behavior of the threads, basically, so that our threads can actually consume this method. So every thread has a runnable method. In this runnable method, basically, we're going to do is we're going to call this method take. So this take method, I mean, this worker method is going to continue taking the job and then execute. Basically, that's the idea. So to be able to keep a thread running, the easiest way is you can use a while method, and while method is going to run based on a variable, or that means we can use this interrupted. As long as this thread is not interrupted, we can keep running it. And the idea is, so basically the first thing it would do is it will take, let's create a variable over here. This is our job, and in the job, in the runnable, we know there is a method called run, right? So we can just execute this run method over here. Now, I mean, this take methods actually throws an exception, right? So we are going to handle this over here. So let's surround it with this try catch, and in this exception, we're going to actually interrupt this thread. The interrupt basically is going to do exit this thread. Basically, if there is an exception, we are going to exit this thread. Basically, that's what it's going to do. And let's move this method over here. So what we're going to do is job.run. That's all we're going to do. All right. And there is one more thing though, which is I'm going to do later. So this working, we should provide a name, and we're going to create a loop over here. So we promise that we're going to come over here again. So now let's create some worker. So the loop is going to be like the thread count. So if the thread count is 20, we're going to run this loop until the 20 until the thread counts, and we're going to create the threads. Let's say worker, new worker. And the good thing is we should name this thread. I mean, if we need to log or we need to some sort of we're not definitely using any kind of log over here, but if we need, we should definitely use some sort of name. I mean, we can, for example, we can name worker 1 or worker plus I. That way we'll be able to know which thread is running what, and we can print some useful information if needed. And the other thing is we can definitely add all of this thread in a thread group. Let's create a field over here, ThreadPool, not ThreadPool, thread group, new thread group, and let's name it something my thread group. You can definitely name something else. It's up to you. The reason is we are going to add this thread to this thread group. If we interrupt this thread group, all of the thread are going to interrupt it, and that way we can easily exit from this thread pool. So that's the idea. Now we have provided this 2 parameter in this worker constructor. Let's create the constructor. So we're going to have and the thread has some already predefined constructor with this thread group and name. So we can just use super over here, thread group and name. So that's all we needed. And the one more thing is this one basically are going to run unless if there is no interruption happen. But in this thread pool, there might be several other threads, and we want to keep, if even the one thread is interrupted, we want to keep running all of the other threads. So what we can do is we can create, we can have a variable over here, which is private boolean running. So we are going to keep it true. The reason is we want to keep all these threads running from the very beginning, and we can definitely use volatile keyword. The reason is if we change this value, I mean the run is true from the false, this should be written directly in the main memory, so that every other thread can read from there. Otherwise, it may be written in the cache, so that if it is not updated in the main memory, some threads would not see it, and that way that thread might not get, that thread might not stop working, right? So that's the idea. And so we'll add this running method over here. So idea is, as long as the thread is running, as long as the value of running is true and the thread is not interrupted, keep running this thread. Okay, so now we are almost set. So basically we have a worker, and let's worker start, call start. That means this whenever we are going to call this method start, it's going to start, and it's going to keep running until we shut down. So let's deal with the shutdown method. So over here we have a shutdown method. The first thing is we're going to change the variable running is equal to false, and then this thread group interrupt. That way we'll definitely be able to shut down this thread pool. So let's see the demo, right? We have another method over here, which is submit, which is returns the future. We're going to work on that later. Let's see the demo first. So the idea is we have created already pool with the 20 threads, and now we're going to submit some work. So what we can do is we can create a nice lambda expression over here, and we can, let's say our first job is hello world. So this is our job basically. It can be complicated, it can be as simple as this, or it can be extremely complicated, and you can definitely have some complex methods over here, complex work over here, but that's for this case, let's assume this is what we have. And we can keep adding some other task, and for example we can definitely replace this lambda expression, this with the lambda expression one liner. Let's make it one liner. Okay, and let's say we have added 5 tasks now. So basically we are now in the main thread, right? And in the main thread, from the main thread, we are actually submitting some tasks to the thread pool. And as long as but the thread pool is going to run, keep running, right? When we are going to actually shut down this thread pool? The best way is, let's keep this main thread alive for a few minutes. I mean, let's assume thread time unit sleep time unit minutes sleep. Let's sleep the main thread for 1 minute. I kind of we are kind of sure that running this 5 hello world would not take more than 1 minute, so we're sort of assuming it. And then we are going to shut down this pool, so that way we'll be able to show that this shutdown actually worked. Okay, so let's run it. See, all of the tasks are actually executed. Now, if we want to print from which thread it is running, we can do some interesting things over here, which is let's extract this system out println this line into a method. So how we're going to do that? Let's just call it print. Replace all. So we have a nice method. And now before actually printing hello world, we can print the name of the thread current thread, and name, get name, and we'll use a plus operator, and we can add a colon over here. So now if we run this again, we'll be able to see which thread actually run which one. So basically the worker 4 actually run the first one, worker 2, as you can see all of the thread actually used, so 5 tasks actually evenly distributed to the some of the threads. Okay, so if we have like 1,000 tasks, then definitely 1,000 tasks will be distributed to the I mean, you have 20 threads, so 1,000 tasks will be distributed to these 20 threads. So this is the idea basically, right? So that's that's all. But we have one more thing to deal with, which is the future callable. This one is a little complicated than the one we just demoed. The reason is we definitely have to have a reference of future, and then return it. Let's work on that now. So now let's work with the future one. That is, if we want to get some data from the task that we are going to submit in the ThreadPool. So now the problem is we have over here a blocking queue which takes only runnable, and runnable doesn't have anything, right? Runnable doesn't return anything. It just return the return type of this runnable method is quiet. So how can we use this blocking queue and with this callable method, a callable job, right? We cannot add these jobs to this blocking queue. We definitely not going to add a different queue for this callable, because then that we have to deal with so many other things. For example, the worker worker has a simple take method, right? It just takes the jobs as a runnable. But if we have a different queue, then we have to decide from where this thread is going to take the first one or second one. That's a lot of complicated stuff going to happen. We definitely don't want to deal with those things. So there is a simple solution though, which is we can have a um, have a class called feature task. Let's get a private class, feature task, and it's going to be a generic one. And okay, so it's we were going to implement, let's name it provide, let's name it class. It's going to implement runnable and also future. So that's going to be our feature task, and let's implement this method. We have many methods over here. Okay, so let's not these are not that difficult. And in this feature task, we're going to have a private field called callable t callable, and we were going to have a constructor using this callable. Okay, so the idea is this feature task is actually runnable, and it also has a feature. It's also a feature. Now what we're going to do is in this submit method, we are going to create feature task t new feature task, and inside the constructor we're going to provide this callable, basically this job. So this job is going to be here over here, and we're going to deal with that later. So from here, this things is simple. We have a task which is itself runnable, and it takes callable as an argument. And this task we definitely add this task into the blocking queue, because the task itself is a runnable, right? It implements the runnable interface. It's simple. So our run queue is going to is going to take this task, and we're going to run this task. So the idea is we are providing this task to this run queue, and we have a reference of this task which we are going to return. So definitely the in this demo we are going to do something like that. Pull dot submit. Let's create a method over here first. Private which is going to return a value, let's say integer, and this is going to be an expensive operation. So let's say the expensive operation is just returning 5. That's all it does. And now so this print method actually return nothing, right? But this one is going to return something. So we are going to do something like that, expensive op. And this one is going to return a feature, right? This feature. So basically the data of this operation is going to be in this feature. So we can definitely get this result, submit that get using this one. So we'll be able to, whenever we are going to get call this get method, we are going to get this value, which is in our case it's going to be 5. But I mean, if we have some expensive operation which might have different things, we're not dealing with that. So this get method actually throws an exception. Let's deal with that for now, and let's print it. The problem with this get method, though, this is a blocking operation, and let's not discuss about that now. We'll definitely can discuss this later. Let's just implement this this class. Okay. So what are we going to do over here is we're going to run this callable method. Sorry, this callable. Which is call, and this is going to return a value which is going to be our result, and this call throws an exception. So let's deal with that. surrounded with, we're going to and we're going to this is going to be our result. So we have a get method right over here. So this get method is basically going to return this result. So we definitely have to store this result over here. Let's create a field which is going to be T. We don't know the type of T yet because it's a generic. Now we can definitely assign this result is equal to result, right? And we can say we can return this result from over here. There is a problem though. There is a problem which is I mean we can immediately get this call this method get, but what if the run is not executed yet? It could be, I mean this run is not is going to we don't have control over it because we don't know when it's going to be executed. ThreadPool will decide, the operating system will decide, right? So there is a one way though, which is we are going to wait until this result is available. So that there is a few method over here, which is done, is cancelled. Okay, so let's work on that. So let's create a value over here called private boolean done, and we are going to declare it volatile, the reason we explained earlier. And let's declare this result as a volatile as well. Okay, so by default it is going to be false, and we're going to change this value done from false to true when actually we are done with this execution. So this done is equal to true, and we can have some exception over here as well, right? So if we have that, what we're going to do is we have another method over here which is called is cancelled, and let's have a variable. Let's have a field called private volatile boolean cancel, which is going to be false by default, and we will make it true when if there is an exception. So let's do over here. Let's make it true. So we can add these. It doesn't matter because we have only one variable and we don't have any other variable over here. A local variable, we don't have any local variable over here, right? So we can remove this, but it's nice to have. It's look nice. Now we can definitely return this cancel, not this cancel. Okay, false. We'll deal with it later. So this cancel is done, and this done. Now the easiest way is we can keep waiting this get method as long as the result is not populated. How can we do it? We can simplest way is while is done is false, keep waiting. This is not definitely the right way, or this is not the good proper way, but for our case it's going to work. So the idea is as long as this done is not true, the loop is going to keep running over here, and once this loop this while loop breaks, I mean when the result actually done, then we're going to get this result. Otherwise this get method will be stuck over here. Okay, now the question is how we're going to cancel. So the idea is if the work already done, we don't need to cancel, right? So we can just check it. If is done, then return false. So false because we are not we are unable to cancel it because it's already done. We don't need to do anything. Other than that, we just call it this interrupt thread parented interrupt. So that way, and if it is interrupted, we can definitely say return true, which means we interrupted this thread. Okay, that's all we need to do. And there is another method called get. which has a two parameter. One is timeout and another is time in it. Basically, the idea is idea of this method is we're going to wait a certain time, and if someone call this method, he is going to wait for a particular period of time, then he will probably move to something else. This is going to be a little complicated. We're not going to implement this in this demo. Let's work on this one. Okay, so we're almost done. Let's do a demo and we should be able to see the result of this integer. Let's see, let's run it. Okay, it's null. Let's debug it. Why it is null? So I have found the issue where we're getting null. The reason is we're making this done is equal to 2 before setting this result over here. So when it is done true, we are returning the result, right, but the result is still null. So what we're going to do is we're going to put the result first, and then we're going to change the value of done. Okay, so now if we run it, we're definitely going to get the result, right? So that's all for. So this is all about our simple ThreadPool. Again, this is just underlying the idea. This is not definitely the perfect one, and don't use this in production. This is not the accurate implementation as well. And this is just an idea how ThreadPool could work, and you can definitely. This is definitely would help you to get some ideas, right? How it's underlying concept. So that's all. Thank you. See you in another video.